Okay, so in this video I would like to discuss examples for Doppler effect. So I would like to discuss question 20 and 21 in tutorial question. Okay, so here, first example, we have a boy standing at the bus stop. So obviously, when it is standing, the person or the observer is not moving, stationary. When the fire engine with a velocity of 40 meter per second, so when you write down the information, make sure you write down the correct subscript. Like this one is the source, so Vs equals to 40. Okay, so VO is observer, Vs equals to 40 meter per second. The frequency emitted by the sirens is 550. That one is your F. It's a constant value. And then you have a situation where the fire engine is approaching the observer, and for B, it's moving away from the observer. And basically you want to use the only one formula. Maybe I can take from previous one. I just want to take it from here. Let's copy. Okay, so for the first situation, you have to ask yourself for A, right? When the fire engine is approaching the person, you have to ask yourself, does you hear frequency higher or lower? Okay, so you can imagine the fire engine is coming towards you. Obviously, FA is bigger than F. Okay, so if that's the case, you have to choose the top one. Now it becomes much more obvious. FA is equals to V is basically speed of sound. Just put this one as 330 meter per second. They should give you inside the question 330 plus VO observer is equals to 0 over 330 minus V of the V source, which is 40. And then you have to multiply with the source frequency. So your FA now becomes 330 divided by 290 times 550. I got here 625.86 hertz. Okay, and then you want to apply the same formula. Okay, except now you have to think about this situation. You have the fire engine now moving away from you. Okay, so the apparent frequency should be less than the actual one. So you want to choose the bottom one. Okay, so here FA is equals to 330 minus 0. Observer still not moving. 330 plus Vs, which is the source, 40, multiply with frequency of the source, 550. So FA is equals to 330 divided by 370 times 550. Here's 490.54 hertz. Okay, so once you get these numbers, you can double check. FA should be bigger than actual F, which is 550. So it makes sense. Most likely your calculation is correct. So in the second example, you should get FA less than F. So 590 is smaller than 550. Again, it makes sense. Okay, just to check. Okay, let's say if the question asks you to draw a graph. So in this case, they didn't ask, but let's say if they ask, if you want to draw, first of all, you draw the axis like this. Okay, I draw it already. And then just label the three frequency that you have. Okay, the higher one, the F, and then the lower one. So F is equals to 550. And then the higher one is 625.86. The lower one is 590.54. Okay. Now you just draw two lines over here and over there. And then just draw a straight line crossing the middle part there. And draw a little bit of curve. Oops. Draw a curve. Okay, so draw an arrow. Okay, so this is the graph that represents the situation. So coming towards higher frequency, this is the source frequency, and moving away is this one. Okay, for question 21, it says that a sound source can produce a sound of frequency 300 Hz. That one is your F. Move away from a stationary observer. Okay, maybe you can imagine police car or something. Okay, this got a little bit confusing. Which one is the front side? So I just label the direction V. Okay, so it says that this source is moving away from stationary observer. So VO is equals to 0. The observer noted that the frequency of the sound heard changes by 10 Hz when the source is moving away. So basically delta F is equals to 10 Hz changes. Determine the speed of the sound source. So the question wanted to find V of the source. Okay, so you know that the source is moving away, so you have to ask yourself, does the apparent frequency higher or lower? So it's moving away, you should hear it at a lower frequency. So you know that FA is less than F, the actual one. So the difference is already says that it is 10. So if the actual one is 300, then that means your apparent frequency is equals to 290. Less, right? Lesser than the actual one. So you want to find Vs, you can use this formula. And since this one is lower frequency, we use the bottom one for sign convention there. So 290 is equals to, again, I use V equals to 330. This one is speed of sound. So 330 minus V observer, which is equal to 0. 330 plus source, which is what you want to find, Vs. And then multiply with actual frequency, 300, source frequency, 300. Okay, so basically 290 divided by 300. Okay. And then 330 divided by that numbers. Okay, I got here is 330 plus Vs is equals to 341.379. So your Vs is equals to 341.379 minus 330. Got here is 11.38 meter per second.